recapture some important points and important slides. So that gives more insight for the people who have not joined last time. So I request Shekhar to again to have certain important points then for the class. Thank you, Dr. Shekhar.
Thank you, sir. I'll just go through quickly through the last class, and we have a little bit of matter that needs to be added, and I added that, and we will conclude this class today as well as possible. So, as you know, the class is about artificial intelligence and computing in anesthesia. And coming to the introduction, I'm quickly recapping whatever I told last week. So where are we now? We came from here to here. So we came from being created to the creator. So we are creating AI now, and that doesn't mean we are gods, but we are creating something that can be quantified and statistically analyzed. So coming to the next, are we new to the AI? We are not new to the AI. Day in and day out, we are using all these apps, as you can see here. All these apps we are using. Whoever is using Apple, they know about Siri, and whoever is using Google, we know about OK Google, and whoever is using Amazon, Amazon Play or something, they know about Alexa. So the recent one is the ChatGPT, and in the middle there is one blue circles there, that is the AI developed by Microsoft, that is Cortana. So coming to why AI, why you need AI in your life to make the things more simplified, because we as an anesthesiologist, we have to be more vigilant during our intraoperative and perioperative period, and we need more hands to do things, and at a time we are not we can be managing more than one cases in most of the situations. In that that will lead to decrease our vigilance, and because we are after all we are humans, we cannot be vigilant for extended periods of time and identify the signs. So this AI, if an issue has been discovered, it must be addressed and as soon as feasible. That's where AI helps in. It would be beneficial if automated decision support is there, because AI will detect the patterns and analyze it and give the output for us, so that we can do we can intervene as early as possible and do the needful. So there are most of the AI is associated with clinical decision supporting system, machine learning, and blockchain technology, where these blockchain technology and the clinical decision supporting system play an important role. So this machine learning is, I will explain about the machine learning in a later period. And coming to the, how does it helps to us? How does it help? Technology improvements have been made the anesthesia practices safer. So as you know, previously in our 20 or 30 years back, we don't have this much technology in anesthesia. We used to palpate the radial artery and or the facial artery at the temporal bone, and we used to calculate what might be the BP, what might be, that's all individual perspective, whether the BP is dropping or the heart rate is going down. We came from there. Now we are using our monitors and everything. We can be able to detect whatever is happening. We are quantifying the things, and we are giving the medications according to the problem, and we are managing the medication. We are giving the medications according to we are assessing the depth of anesthesia. We are assessing the pain, and we are addressing them as quickly as possible and as early as possible. So there is an exponential increase in the electronic medical data these days, so which enabled AI and other algorithms to create the clinical decision supporting system. So this is where AI helps. You don't have to remember everything for you on your own. That is very difficult. We cannot remember all the data on our own. So this medical data can be converted into the electronic data, and it can be stored, and it can be incorporate into the AI, and it will give the patterns and it will give the decisions, and it will help you in future when you are in a critical position. So this leads to quick and appropriate intervention. As you know, it will decrease the errors, deficits, and incidents in the operation theater. So coming to the next one, how to do it? How to do it means we have to develop a case cohort system. We have to collect the case cohort data. We have to visualize the data sets. Visualizing data sets using the inbuilt AI, and we need to use these data sets to build by the graphing tools which are present in the monitors, and at the same time executing the client machine learning, inclined machine learning, and exporting this data, storing this data, and exporting this data to the outside so that we can use that data. So then coming to the introduction part. So coming to the nomenclature part, we will learn about these things in this nomenclature. We will learn about what is the definition of artificial intelligence, what is Bayesian network probability, what is AI logic, what is management information system or hospital information system, and what is data mining, what is machine learning, and what is deep learning, and also what is blockchain technology. So coming to this, the first thing is artificial intelligence. Artificial intelligence is defined as the study of algorithms that gives machines the capacity to reason and perform activities such as problem solving and object and word recognition, inference of world states, and judgment making. So it performs, it reasons, it performs activities, it solves the problems, it identifies the objects and the words, and the inference is given in a more practical manner, and it will help us in judgment making. So coming to the next part, what is probability? How does AI works? It works on probability. The basic probability is Bayesian network probability. It is defined as the study of algorithms that derives the probability of multiple cause and effect relations. As you can see here, this is a particular example about the season and the atmospheric pressure. The change in season and change in atmospheric can lead to, can the change in atmospheric pressure and or the change in can lead to makes a cat hide? Yes, it can. How? You can follow if there is change in, if it is a rainy season, the dog will bark, and when the dog barks, the cat will hide. That's the probability of cat hiding and season change. Same for atmospheric pressure. What happens? What is the possibility of using an umbrella on a particular day? It depends upon the season. The season will, if it rains, you will use umbrella. Otherwise, you will not use. That's the probability. That's how these probabilities work. At the same time, allergies. When will you get an allergy? When there is a seasonal change, you can get an allergy. That's how it is. So it's a simple probability network, basic probability network. That is coming to the fuzzy AI logic, and coming to the AI logic. Every anesthetic monitor is a sentinel monitor. This sentinel anesthetic monitor monitors all the trends. It identifies the ill-defined trends, and it also learns from the physiological data streams, and it forms a fuzzy domain pattern. I will explain what is fuzzy domain pattern. It creates a fuzzy trend templates, and it applies the logic. This logic is dependent on two types. So this logic is, the basic logic is Boolean logic. The Boolean logic is, if you ask a question, it will give in 0 or 1, that is yes or no. So if there is a simple question that is given as yes or no, that is known as a Boolean logic. Okay, for example, it is hot. It is either you can say it is hot or no. That's the basic logic. That is, if it is yes, it is 1, or if it is no, it is 0. So, but what is fuzzy logic? Fuzzy logic means it divides the logical question into so many things that it defines its whether it is very that depends upon the input of the character. So whoever is using that input, we are giving that input, that will assess it according to that input. So is it hot? It is very much hot for someone. It is fairly so for someone. It is moderately slow for moderately hot for someone, and it is somewhat hot for someone, and it's very little hot for someone. That is depending upon the experience of the person at that point of time. So all these things will lead into it uses all these inputs and gives the logic. So this logic is applied onto the So in identifying the patterns. So what is fuzzy pattern? If the controller will give the inputs, these inputs will go into a fuzzification interface. These inputs are made into different permutations and combinations and in the fuzzification interface, and it will give the fuzzy inputs. So there are a lot of, if you give 2 inputs or 3 inputs, it will intervene. It will make into different permutations and computations of these 3 inputs, and it will give the more than 3 fuzzy inputs. These fuzzy inputs will give into the inference engine, where it analyzes that fuzzy inputs, and it will give the fuzzy outputs. These fuzzy outputs will again defuzzified, so that whatever is necessary will be included, and whatever is not necessary will be left out, and it will give the controller outputs. But one more thing here is, we can intervene into this fuzzification interface or inference engine or defuzzification center depending upon our knowledge base. If the knowledge base is, you can always give if the fuzzification interface is leaving an input that is important to us, you can always intervene in that, and you can include that. At the same time, in the inference engine also, you can use your input or knowledge input. You can give the knowledge input from the knowledge base and make it more reliable. And at the defuzzification interface also, you can remove whatever it is necessary, which is giving the fuzzy outputs. Some of the fuzzy outputs may not be important to you, but it is important to the computer. So you can always remove that unimportant things, which is more analytical towards depending upon the knowledge base, or you can incorporate whatever the inputs, whatever the outputs that is left out by the fuzzy inference engine. So you can always intervene in the defuzzification interface also, and you can cut the outputs. Once the outputs came out, they will give a feedback to the fuzzification interface, so that in future it will include or delete the inputs from the controller outputs. These controller outputs will act as inputs now. So from these inputs, it will always analyze onto it and gives the next outputs in a different manner. So this fuzzification interface, this knowledge base, inference engine, and defuzzification interface is known as fuzzy control unit. So coming to what is management information system? Management information system is a computer-based information system which is used as it can be called as a hospital information system that is used by us. So it's a codified computer information system. It can combine data from numerous sources and give managers or the health workers in our community so the information required to make decisions. So you can see it collects data from the patients. Here it is given as people, but it can be patients also. It can be a procedural data or just an OP data. It can be procedural data for an inpatient and an OP data from the outpatient. It will always analyze the procedural data, and it will always stores that OP data. It stores all the data from the procedural data and from the filing system, and it will generate manually produced reports. This is the basic hospital information system. Coming to data mining. What is data mining? Data mining means it's just like the process of analyzing the data in search of hidden patterns. Sometimes we will not be able to recognize the patterns inside because medical knowledge is so vast that we cannot be able to comprehend what is going on with the patient sometimes. So in such cases, we can use data mining to analyze the data in search of hidden patterns. So data mining techniques enable to discover us the previously unknown links because of the data sets and clustering of the data, and display the connections between the data points and ability to make predictions depending upon the data and the previous because of this unseen patterns. So there will be 4 stages in data mining. There will be data gathering, that's your EMR, data preparation, and data mining. Utilize the machine learning to so that you can identify the hidden patterns, and there will be data analysis, which will be given in as graphic trends or a statistical analysis. So coming to data mining. What is data mining? So data mining will include, first the data sets will be taken and they will be pre-processed. There will be classification and it will store as a database, and it will based on the database it will give the statistics, and the statistics will be analyzed by the computer and it will give the final evaluation. This is the simplest form of understanding the data mining. So coming to the next part, what is machine learning? Machine learning is one of the most essential components of AI. So once you know what is machine learning, AI depends upon machine learning in understanding the data. So machine learning is a process by which the computer analyzes the collected data, which develops the models to predict the outcomes without explicit programming. So the methods and algorithms involved in machine learning include, as I said, fuzzy logic or classic machine learning or deep learning or Bayesian methods. Any of them will be there depending upon the complexity of the AI that you are using. So the process by which the data is analyzed by the computer, which develops models and predict outcomes without explicit programming. As I said earlier, that's the machine learning process. The data that could be fed to the system could be of high volume, but it is beyond our limits of intelligence. That's why we use machine learning to process this data. So classical machine learning can be further classified into supervised learning, unsupervised learning, and reinforcement learning. So we will go through this in a minute. So coming to the supervised learning. Supervised learning is the goal-directed process where the program is trained and predicted the predetermined outcomes. So that the outcome is fixed. It is a supervised learning we use regularly in our problem-based workshops. Problem-based workshops, we use the output will be determined by the controller, and the inputs are given to the whoever is attending the workshop, and we are already given the output. This is the output you have to get. You have to save the patient, or you have to go. Your target hemodynamics are this. How will you approach this patient from here to here? So that the output is fixed. So this is a training data that is fed into the system, which you analyze where the computer analyzes and gives the desired output. So same as in the workshop, we give the inputs to the person who is attending the workshop, and he has to deduce that to the final output so that he can get the desired output. This is supervised learning in short. So coming to how supervised learning, this is the step one of, sorry. So this is supervised learning. So providing the machine, the thing is, the machine learns. These are all cats, as you can see here. These are all cats, and you will if you find this, you have to identify them as cats. That's the input that we are giving. That the data that is inference that is we are giving to the machine. So when you give a question, how many of them are cats? It will identify the cat faces and it will give the cats. It will just say whether it is cats or not cats. That's it. So this is classic supervised learning. So it will give the classifies the data into whether the data is applicable to us or the data is not useful to us. That's the only thing that is supervised learning does. So coming to unsupervised learning. Unsupervised learning is a deep learning from supervised learning, where the programs and data identify the specific pattern and from our structure from the given set of data. It will not conclude anything. It will give it will just identify the patterns. It is used to learn and identify newer relations and methods of classifying drugs or identifying the diseases. So coming to unsupervised learning, you will input the raw data. As you can see, we gave some vegetables here. It will interpret based on the algorithms. It will process and gives the outputs depending upon the interpretation and algorithm. And it will give, as you can see, it just sorts out the patterns. Other than that, it will not do anything. It will not identify it as brinjal or onion. It will just gives the patterns that these patterns are similar. These patterns are similar and these patterns are similar. That's it. Coming to reinforcement learning. Reinforcement learning, as you can see, So it's a feedback from the outcome which influences the algorithm continuously to make the future predictions. That's the positive. It can be a positive feedback or a negative feedback. The positive feedback can give the successful interference, or the negative feedback will give the negative feedback will also help us in modifying the algorithm. So you can see there is an agent and there is an environment. Here the agent is the dog and the environment is the actions made by the dog owner. So depending upon the agents of actions of the agent, it will give the rewards. The controller will give the rewards and gives the observations and reinforces the agent to make more actions, and it will give a positive feedback. If there is any aggressive behavior from the dog, that's a negative feedback that will be rectified by the dog owner in the future. So that's how reinforcement learning works, where the data is input, it will give the raw data, it will go through the environment agent, and it will give an output and sorts the data. It will not, it's clustering. It just clusters the data, and it will not identify the data as whether it is yes or no. It just identifies the data and make it into clusters and gives the output. So coming to coming to the coming to machine learning in short, the machine learning is, as you can see, there is a supervised learning. The supervised learning can be it can be given an output as classification or regression. In a classification output, you'll identify the detection, you identify the fraud detection or image classification or customer retention or diagnostics. This is the supervised learning that is given, because diagnostics, the data should be between these values, or the output should be between these values. That's the output data. Output, that is the target value that we are giving. If it is out of that data, there is something wrong. That's the classification that is given in diagnostics. So coming to the regression, it can be used in advertising, popularity prediction, weather forecasting, market forecasting, for us in estimating the life expectancy and the population growth prediction. Coming to unsupervised learning, it is more of a discrete values. It is a big data. Either it can be clustering or can be dimensionality reduction. It is used to comprehend a meaningful compression or a feature elicitation or a structure discovery or a big data visualization. It's a bit deep than the supervised learning, and it will recommend the systems. It will in clustering, it will identify the target market, and we can also go to the customer segmentation. How will you differentiate the customers? And in reinforcement, you can use in learning tasks, robot navigation and real-time decisions, and game and skill acquisition. This is how the reinforcement learning in machine learning works. Coming to deep learning. Deep learning is utilizes the neural network for processing the data. Deep learning is the thing that we are using in our regular medical uh, information systems. So there is a neural network that processes signal in layers and includes computational units. And these networks are made up of an input layer, and a hidden layer, and an output layer, which are interconnected. This, as you can see, the data fed through the input layer, and it processed mathematically into the hidden layer, and the predictions are passed to the output layer. So the modern these days, the data learning involves more than one hidden layer. The more the more the hidden layers are there, the more the complex the deep learning is, the more the complex outcome will be. So that it forms a convolutional neural network, just like brain. It forms a neural network, and it gives a deep understanding that process the data in multiple layers and multiple arrays, and it is ideal for analyzing sequential data. So coming to how a simple deep learning can be identified. So you are giving inputs at this layer. This is called the input layer, or the placeholders, and these inputs will give all the inputs will be analyzed in the hidden layer, and it will give the output to the it will give the inference to the output layer. In the output layer, it will form an artificial neuron. This is the web network that developed by the deep learning, and it will give an output as y1 or y2. So your outputs can be different, but your neural network will analyze all the data that is given in the input, and it analyzes and it will gives your output. So you can see here, you can see in the bottom, there is a number of patients' data is there. There are 5 patients' data here. This data is given as input, and it analyzes in the input layer, and there are almost n number of hidden layers are there, and one output layer is there. So these all hidden layers forms the artificial nodes, artificial neurons. These artificial neurons will analyze this input and gives the it goes to a web of network and gives the output as yes or no. So that's how it is. At the end, the output is actually desired, or actually output is not desired. That will also give in this deep learning. Deep learning is very advanced, and deep learning helps us in predicting the statistical data and predicting the outcomes of the patients depending upon the number of inputs that we give of his health status. So continuing on deep learning, in contrast to classical learning, where the data is handcrafted, deep learning learns from fed data. It will not, you cannot interfere into the data. Deep learning learns on itself. It is the most common and highly advanced part of AI in anesthesiology. So you have to have a case cohort data for this. As I said earlier in the previous slide, you have to have the visualizing data sets and the graphing tools in the monitors, and it will also analyze from that. It will execute the machine learning. At the same time, it exports the data for external use. That's how it is. Continuing on deep learning, in contrast, as I said, this it's duplicated. Sorry. So for this, in our medical knowledge, what we are using these days is Opal. Opal is a web-based supporting system. It is a cloud application. It is used to build the web framework for healthcare applications. It's an open source software. It is free of cost. It's more secure, and it is client-based. And it analyzes the automated data system. It gives the evidence and evidence for evidence-based perioperative practices. There is a lot of data that is stored in the Opal network, and this is it also reduces costs. It enhances patient outcomes, and it runs on Python. So coming to how this deep learning works, just giving an example. You have an ECG, you have an photoplethysmography, and you have heart maps in your monitor. So it analyzes ECG and heart maps. It analyzes plethysmography and heart maps. And another subplot that analyzes ECG and plethysmography, and it will go through 2-channel convolutional neural network, and it goes into the deep learning models and gives the output whether the anesthesia is deep, whether the anesthesia is okay, or the anesthesia is light. So depending on that, you can intervene into the anesthesia, into the patient's. You can give a painkiller, or you can give you can increase the depth of anesthesia, or whatever it is there, or you can lighten the patient depending upon your requirement. So coming to machine learning, what is the difference between basic machine learning and deep learning? As you can see, there is an input, there is an extraction, classification, there is an output. So in machine learning, the feature extraction is controlled by manually. It is controlled manually. But in deep learning, the feature extraction is automatically done by the machine. So the input is given. Just we will have to give the input. It will analyze its feature. It will analyze and extract the features and classifies and gives the output, and it also gives the reasons for the outputs. So what is blockchain technology? Blockchain technology is a novel thing, and it is derived by Satoshi Nakamoto. As you can see, Satoshi Nakamoto is a pseudonym. These are all the people that developed blockchain technology, and the paper is presented by Satoshi Nakamoto, who is nowhere. So Satoshi Nakamoto is a pseudonym. So the blockchain technology is an advanced database mechanism that allows transparent information sharing within the business network. It's more transparent. It stores the data. It also stores the data in blocks, which are linked together in a chain. That's why it's called blockchain. This is the first technology that is used. This is the technology first used by Bitcoin. So BCT has an important role in healthcare, pharmaceuticals, health insurance, and genomic industries. Coming to BCT, it replaces the traditional methods of data storage. It has 4 categories. What is that? The asymmetric, I will tell you in a later part. Asymmetric supply of data chain and transmission will be there, and it lessens the reliance on centralized internet server, and it protects against the potential of catastrophic failure. It enhances reliability and redundancy. So the 4 categories of BCT are data communication, consensus, and application. So coming to how BCT works, when a client asks for a transaction, or when a physician asks for a transaction, it is requested, it is given into the different network nodes, which is given into the, these nodes are made up of manual people only. They identify whether the transaction is secure or not, whether the transaction is valid or not. And if they verify the transaction, it will gives the, they will work on it and gives the output, and the transaction is combined with other transactions and made it into the data is stored. The data is collected from all the net nodes. As you can see here, there are 4 nodes. All the 4 nodes, they store the data, and this data is given to the next part, and this all data is stored as a block, and a block is created, and the transaction is finished. You cannot intervene in between. Once the block is created, it is final. So you cannot intervene into that block again. You can only arise another question or another transaction, so that another block is created, and this block is linked to that block. So that is how blockchain technology works. So there is, what are the advantages of blockchain technology? So it is more decentralized. It enhances security. It has a faster settlement thing. It is irrevocable or auditable. It is immutable. It is, hello, మళ్ళీ చేస్తాను ఒక నిమిషం. నేను మళ్ళీ చేస్తానండి, ఒక అరగంట క్లాస్లో ఉన్నాను. అక్కడ ఇచ్చేసేయండి, నేను పంపిస్తాను. అక్కడ ఎమర్జెన్సీ దగ్గర ఉన్నారా మీరు? వాళ్ళకి ఇచ్చేసేయండి, నాకు ఇస్తారు. ఇచ్చేయండి. డాక్టర్ శేఖర్ అని చెప్పండి. Sorry for the interruption. So it will have a faster settlement rate, and it has auditable and irrevocable. That's the main thing. And it is immutable, and it is not non-reproducible, and it is also repudiable, and it is also transparent and provable, and it's a trustless operation. Trustless means that doesn't mean it doesn't have any trust. We shouldn't trust it, because it will not trust anybody in that block. It will not trust anybody. The data is created by number of nodes, so that it will not trust one single person or a single unit. And it's a digital ledger, and it can be distributed to any parties and any number of people. So that's how blockchain is more in. So coming to the applications of
BCT and Mali Chapwa.
Sir, it is block and chain, sir. It is block and chain. Once, if you, I will tell you, if you ask for a transaction, if you ask for an input, if you give the input to a particular person in the blockchain, it will verify whether the input is valid or not first. If it thinks it's valid, it will give that it will give that input to the number of people in that network. So these number of, if it gives 4 people, If it gives 4 people, the 4 people will collect data on it and make a and forms a digital ledger of it, and they store their individual individual ledger with them. This ledger will share to the next person. So all the 4 data from the 4 persons will be collected as the digital ledger in the next machine, next step. I will show you. Yeah, here. So so all this data from these 4 people, you can see here 4 people are there, who are working on computers in the step 3. So all this data is interlinked, and this data is transferred to the next person, and the data is created there, and this data is stored as a block. This data is verified and stored as a block in that new ledger. This block, once the block is created, that transaction is finished. You cannot intervene again into this block. That's the chain. This is a chain and a block. So this chain, because there is no single person is having the full data here, it is more reliable. Once the block is created, you cannot intervene into that data. You cannot give any input into that data, and you cannot disturb that block. If you want anything else, you have to again raise another question, and that question will be answered in the same way, and this block and that block will be changed, so that you will get a final output depending upon that. Understood, sir?
Yeah, understood.
Yeah, so that's how the blockchain works. So coming to the applications, how AI works. As I can see, AI can aid for an anesthesiologist in the perioperative period for risk stratification, prediction of difficult airway, checking the completeness of the preoperative checklist, and suggesting appropriate antibiotic. The role of AI is extensive in the intraoperative period, including dexterity-based function, drug administration, monitoring, and risk prediction. So as you can see, the most popular one is the Kepler robotic system, which has a 91% success rate, and the average intubation time is 93 seconds. So another one that developed after Kepler robotic system is remote robotic assisted intubation system and automated intubation system, robotic system. So these are all more advanced than Kepler robotic system. And the last one is the robotic endoscope automated via laryngeal imaging and tracheal intubation. That is the reality. So this is the Kepler robotic intubation system. We all know this famous image. So it just we have to operate this joystick and the controls, and we can intubate. The machine itself intubates the patients. Coming to the remote robotic assisted intubation system, this is more useful in trauma patients, where the patient and the care provider are at a distance. They can using Wi-Fi and web-based application. You can see the patient, and you can remotely intubate the patient. So this is the machine that has a joystick here. You have a joystick. You can see the patient is the controller is holding the joystick, and he is seeing the image on the screen. The control system is with him, and this intubation robot will be taken by the trauma people to the thing, and it will fix. They will fix it on the patient's around the patient, and the controller here, the care provider will just operates the joystick and intubates the patient. So coming to reality, as it is endoscopy based, as I said, and it utilizes the laryngeal image. So the most important here is it is endoscopic, and it utilizes the laryngeal image as the guide. So as in a normal intubation, we use this. As what you have to do is just intubation will the intubating system will enter the mouth. It will guide itself up on its own. As you can see, there is a camera at the end of the endoscope. and there is a rigid shaft for this is the handle, this is the joystick. Joystick is all included in the handle, and there is a processing unit, and this is a highly flexible tip. It can be this is the articulated section, and it is highly flexible, and it can move on its own depending upon the laryngeal imaging that I will show in the next slide. So it first identifies the glottis, it identifies the cartilages, it identifies the glottis, it identifies the glottal opening, and it identifies the trachea, and then it intubates the patient. So that's how it is. How it will identify all this? So it will identify first, first of all, it will identify the cartilages. That's the stage one. When it identifies the cartilages, it will have a blue block there. And after that, it will identify the glottal opening, whether the glottal opening is adequate or not. Then it will give a, if you identify only glottis, it will identify the as a pink, and further it will move forward and identify the total glottal opening. And identifies the total glottal opening, then it will turns into orange block. And when it enters the trachea, it will give an yellow block that will identify it as a trachea, and it will intubate then. How AI helps in anesthesia? So in pre-anesthesia care, in perioperative, in risk stratification, as I told, you can include ASA physical status stratification in that. You can also include my surgery risk. You can also detect post-operative delirium and with preoperative risk factors. And it predicts the difficult airway by using facial pictures. And it also checks the completeness of the preoperative checklist. It suggests the appropriate preoperative antibiotic by clinical decision supporting system. So telemedicine in the preoperative period also, and tele-PSCs can be done with the help of AI. So it also helps in educating the patient, preoperative patient education, in decreasing the smoking and cessation of smoking, and initiating the respiratory exercises. So that's how it is. So, and how it also in the intraoperative period, it helps in ultrasonography. It enhances the needle tip in visualization. There is a scan now technology that is there. It highlights the colors, the anatomical structures in real time in using regional anesthesia under ultrasound guidance. So it also identifies the epidural space. It identifies the anatomical structures around the spine, and it estimates the depth of the epidural space, and also calculates the point of needle entry and the angle of needle insertion. So all these things leads to shortening of the duration of procedure. So coming to the next part. So how continuing, it can help in robotic intubation as an remote robotic assisted intubation system or an automated intubation robotic system. And coming to the next, how it helps in it also helps in drug administration, either by open loop delivery system, that is known as target control infusion, what we use, and closed loop anesthesia delivery system. It can be divided into two. Either it can be a single input, single output system, or a multiple input, multiple output systems, which is used in maintaining the depth of anesthesia. So depending upon the depth of anesthesia and hemodynamic management, and in hemodynamic management, it can guide us with fluid administration and vasopressor administration and inotrope and vasodilator administration. Coming to the next important things, it also helps in monitoring by smart alarm enabled with the CDS, clinical reports decision supporting system. It also predicts the risks depending upon the inputs that we given. It also can detect the acute kidney injury. It also predicts the post-operative mortality rate and following cardiac surgery. So how helps in the post-operative period means it assesses the severity of the post-operative pain by facial expression of the patients. It can be used as a wireless intelligent patient-controlled analgesia, and predicts the post-operative opioid use in opioid-naive patients, and post-operative fluid administration, monitoring of the daycare surgery patients through telemedicine. That's how it helps. Coming to the what is clinical decision supporting system. Clinical decision supporting system is developed in 1970, which is very basic. It was very time consuming and with poor integration. It evolved into web-based applications these days. It interacts with the electronic health records and computerized provided entry systems, and it can be used with a desktop, laptop, or a smartphone or a tablet. So we can also use with the new technology, wearables also used in clinical decision supporting system. So there is a strong evidence that trials from the trials that clinical decision supporting system helps in the doctors in providing better care to the patients, where the electronic medical record is goes through this rules engine, clinical expert based knowledge base, and decision learning with machine learning protocols, and it will give the outputs and diagnosis. So this part is where the rules engine is included and the knowledge based parts are included. That's more important in coming to a decision. So what are the types of CDSs? It can be knowledge based, where the knowledge based are instrument in retrieving the relevant data and evaluate the rules and produce an action output. Or non-knowledge based. Non-knowledge based is interplay with the AI and ML. So machine learning and AI comes into the non-knowledge based pattern. It only recognizes the statistical pattern and gives the output rather than being programmed to the current medical knowledge. Coming to, are there any limitations for CDSs? Yes, there are more limitations to CDSs because infrastructure is a big worry. We need a lot of infrastructure. So lot of data needs to be lot of data input needs to be given, and continuous EHR updation should be done, and changes in the existing workflow, because we are not used to this. There will be a change in the existing workflow. There is a difficulty in designing and deploying the changes also. And coming to what is the role of CDS in anesthesia? It can alter the ventilation parameters. It can give the perioperative how to use the perioperative beta blockade. It will also guide us in antibiotic administration. It will also give the blood pressure management program, how we will manage. And it will also
antibiotic ఎలా చెప్తుంది?
Sir?
How it tells antibiotic administration?
Depending upon the entered data, sir. I mean, cultures and whatever it is there. If you enter what are the existing comorbidities of the patients and what is the surgery that we are doing అనేది దాన్ని బట్టి it will predict the antibiotic administration, sir. And patient body weight, patient creatinine status or renal status, liver status అంతా మనం ఇన్పుట్ ఇచ్చిన తర్వాత it will guide the antibiotic administration. Okay. So it will also decrease the anesthesia used by low flow anesthesia. So coming to where further role is, what are the advantages? We can give a thumbs up for CDSs because it will decrease the medication errors, it will decrease the adverse event, it will decrease the it will deviations from the guidelines. It will also gives the better patient outcomes. It will protect us against medical legal litigations. It will also improve our orders in ordering essential preoperative investigations and prevention of duplication. And it's suggesting cost-effective medications to the patients. And it also provides the real-time diagnostic decisions. And in automated documentation, it will decrease the daily workload. Initially, there will be increased workload, but over a period of time, it will decrease the workload. So, how accurate it is? It has a 95% sensitivity and 90% specificity in identifying the postoperative pain, in identifying malignant hyperthermia, in identifying the hypertension and decreased cardiac output states, in hypovolemic shock, and also in increased ICP, detecting increasing ICP, and detecting the shunt fraction. So what is the further applications of CDSs? What is the future of CDSs? So it can possibly help in detecting the perioperative blood loss and intravascular fluid volume, and it can also help us in detecting the depth of anesthesia. So it can be the transformation of established clinical guidelines into dynamic usable tools. It can convert the fixed guidelines into a dynamic guidelines. And it can also managing specific patients in real time. It facilitates the collection of data and tracks the outcomes.
All units, ICU, pre-op, OR, PACU, and general wards.
It involves all the wards, general wards, PACU, and your intraoperative period and the preoperative period and in the ICU. All this data is collected into this, and it will give the anesthesia information management system. It is an electronic anesthesia record. It will be collaborated with the it will contain PAC, simple forms to complex questionnaires, and automatic capturing of the data and from the monitors and the workstation. And it also manual inputs into, we can add manual inputs into that. It will integrate with the electronic health record of the hospital, and it will be stored as an it will integrate itself into the electronic health record. So what are the advantages of AIMS? So it facilitates the preemptive evaluation, and through retrieval of previous records and addition of new data for future use, ensures the patient safety and assistance with medicine dose administration reminders and documentation of adverse events, reduction in anesthesia drug costs, and use of real-time clinical decision assistance system, and in the development of risk management methods and detection of essential key events. It also display of crucial algorithms and instructions such as BLS or ACLS or trauma treatment or poisoning treatment or managing medical or surgical complications. So coming to what are the advantages of AIMS? So it alerts, reminders, notifications for the anesthesia professionals. It fixes OR location errors, and it interprets hypothermia and alarms following cardiopulmonary bypass, and improving compliance of the medications, prevents PYNV, and helps in antibiotic prophylaxis and augmentation in clinical research and multicenter studies. It's also time saving and enhances precision. So what are the difficulties in implementing? Because of reluctance is the first thing, cost and finance are the second thing, distraction of the anesthesiologist from the clinical work is the third thing, medical legal issues, whether this because everything is recorded and everything is, you have to be more vigilant about medical legal issues, opposition in changing the clinical practice. Regular clinical practice, nobody wants to change their regular clinical practice. That's a major problem. So coming to the final part. Summary. So how we can summarize this is, what are the pros of AI? So efficiency is enabled by the cutting edge computer software and hardware technology. So network connection technology and information processing technology. Efficiency is there, but it will CDSS has found to be effectively cut the medical expenses of the patients and minimize the hospital stays, strengthen the standards of operations, SOPs, and aid the diagnosis and treatment decisions made by the clinicians. The system takes into the account of the concept, structure, equipment selection, manufacturer's response, and maintenance capacities, and the spare part availability to ensure the chance of failure in the information system. Chance of failure of the information system is minimized, and there are backup methods in case of unforeseen issues. It will also has the backup methods. Each patient is allocated as a virtual machine database, and the virtual database machines will provide the data services that can be made to the given to the authorized service users, just like other physicians also, so that they will give their inputs into that, and it will develop its own database. So what are the cons? There are more cons. Don't worry, there are more cons, but when it comes to healthcare, big data construction presents with a double whammy of data security and privacy. There is a problem with data security and privacy when it comes to healthcare. It is also important to share. It's also challenging to share the medical data, which is a non-uniform data from the medical records, because there are lack of established data standards of EMR, and the inability of some hospitals to link their internal information systems. So because all the hospitals cannot maintain this, so that's a major drawback. And sensitive data leakage is a serious issue in healthcare industry. Compounding other relations are collection, transfer, and use of patient information is also important. These are also the cons of AI. And identity theft, internet attacks are the new obstacles. So these needs to be overcome by the healthcare industry to move to, and we have to move for more smarter practices. So coming to other cons of AI, because software-defined network-based gateway, it ensures only authorized entities may access the patient's virtual machine, functioning like a firewall. Cost of development is more because everybody cannot, even the patient wants to go through the data, it cannot be seen by the patient or by any other physician who is not in the network. So ethical issues. Data ethics includes obtaining informed consent from the patients, maintaining the privacy and collected data, using it for the right situation to answer the necessary questions is a big issue. And black box results and predictions, which are made by the algorithm, cannot provide information on how it made such a prediction. This will reduce the transparency because there is a prediction that given by the algorithm, but you don't know how it come to that prediction. So if the patient asks how it will coming to this prediction, we don't have any answer for that. That reduces the transparency. So coming to coming to other cons. So although AI is identify patterns and correlation between variables, it cannot be established cause and effect relationship. It will lack the emotional touch that a human or a individual doctor has. It is susceptible to bias. It can be an implicit bias or an explicit bias. In explicit bias because of the sampling errors and lack of diversity, and implicit bias because of the changes in the algorithm. Maintaining the quality of the collected data, that is very big issue. So what is the future of AI? Future of AI is cloud-based things. It can be Internet of Things or the big data or the cloud computing of any sort of thing. It uses the cloud-based data and it will give us more inputs in taking patient care to makes it feasible for giving more precise healthcare. So whatever we do,
cloud-based.
ఆ మూడో క్లౌడ్ బేస్డ్ సార్.
అంటే క్లౌడ్ అంటే ఏంటి అండ్ ఇంకో చోట ఎక్కడ ఉంటుంది అంతే కదా?
సర్వర్ కి కనెక్ట్ సెంట్రల్ సర్వర్ ఉంటుంది సార్. సెంట్రల్ సర్వర్ నుంచి ఇట్స్ ఆన్ ఇంటర్నెట్ అండ్
ఇంటర్నెట్ ఎక్కడ ఉండాలి కదా, ఆఫీసు స్టోరేజ్
ఉంటుంది సార్. దట్ ఈస్ జస్ట్ లైక్ గూగుల్.
ఇట్స్ నాట్ ఇన్ ద క్లౌడ్స్ కదా?
It's not in the cloud, sir. Because we can't see it, that's why it's cloud. It's not in hard data. It's a software data. That's it.
No, I understand what I mean. Like for example, now disposing is a difficult part. How are they going to dispose the clouds?
So the thing is, we need to have. That's what, sir. We need to have a lot of infrastructure to go through these systems. We need to have continuous internet, continuous data, and uninterrupted internet should be there. High speed internet should be there, so that there should be no discrepancies in workflow. So whatever we do, coming to this conclusion, whatever we do in our life, whatever we do with the patients, we will the AI helps us in increasing our emotional touch to the patient. We should be that emotional support or the emotional thing that cannot be created by AI, that can only given by a human touch. So AI helps us. At the same time, we should not be dependent totally on AI or the internet-based things. It can guide us towards the diagnosis or towards the treatment and increase the best outcomes in the patients. But it will not give that human touch which it lacks, or the emotional touch which it lacks, that can be only given by us. That's my conclusion. Thank you.
Even today also took more than 1 hour. It's a really tough and big class. I'm still not getting a real understanding of machine learning, at least a little bit more. Machine learning, what exactly is the machine learning? Still, I am not totally.
Machine learning, deep learning is a bit this thing, sir. Machine learning is just like, as you can see, machine learning, it has three kinds of learnings. As a supervised learning, machine learning means you will input a data, whether the machine learns it or you will make the machine learn. That is important. In basic machine learning, as you can see, I differentiated here. So in a basic machine learning, you will give the data, you will mark what is important and what is not. Then the computer classifies the inputs and gives the output. But in deep learning, you will just give the input. The learning of that input is done by the machine only. It will learn on itself. It will come to a conclusion. It will classify itself. It will come to a conclusion on itself. That's the difference between machine learning and deep learning. But machine learning is more of basic form of deep learning. Any question?
లాస్ట్ టైం కూడా మన క్లాస్ లో చాలా మంది జాయిన్ అవ్వడానికి కారణం ఇప్పుడు ఎందుకంటే లాస్ట్ టైం క్లాస్ అయిందని, ప్లస్ ఈ రోజు నాగుల చవితి చాలా మంది జాయిన్ అవ్వట్లేదు. అండ్ మన కేరళ రాణి మేడం వాళ్ళ ఫాదర్ ఏదో సర్జరీ అయింది. అదర్వైజ్ దిస్ నంబర్ వెరీ లెస్ యాక్చువల్లీ. మన అయితే ఫిజికల్ కూడా.
It's okay, sir. No problem.
Very nice.
Thank you, sir.
Thank you.
Any questions? I think probably PG students might have understood it better than us.
Yeah, because they are new generation.
Yes, sir. What, Kranti? Kranti Kumar. Okay, sir, we will wrap it up. Thank you, sir.
Thank you.
Thank you.